Yes, we will be starting again. Sorry for the tight schedule we're running this morning. Please take your seats, take your coffee with you. It's no problem at all. We will be installing Frank for the first part of this second session. And as Lonneke has mentioned, this afternoon we will have another interesting sessions about the new OCPP testing tool. So please join us for that. Yes, everybody is settled. I will give the stage to Frank.
Okay, so my next talk will be about the work we did in the networking task group. And yeah, I will discuss it. Why did we think we needed something like OCPP networking or routing? And how can we add routing to the existing OCPP specification? Then we had another issue with how we're going to deal with offline nodes, because it becomes much more complicated if you're in a network. And I also mentioned something about security in a network, signed messages.
Take this one. Yeah, is that better? Yeah. Okay, so where was I? The security and signed messages I will briefly discuss, and the kind of use cases that we can support with the routing, and finally the need for some pilot implementations. So why OCPP routing? Well, normally OCPP assumes that you have a client-server connection, a one-to-one connection, and you have no intermediate hops or routing capability. We do have the concept of a local cluster, a local router, local controller, different names for it, but it's not really well defined on how to deal with that or what it can do. But in practice, we found out that routing options may become convenient if you, for example, want to do load balancing of a cluster of charging stations, or the situation where you have charging station in a parking garage where they have no cellular connection because they're underground. Then you might want to have a single hub that has the connection and then simply transfers that information to the charging stations. So in general, if you want to support some localized functionality, maybe even kind of local authorization that's not coming from the CSMS, then yeah, routing functionality becomes interesting. So if you've read the OCPP specification, you probably all know this local controller diagram. It's mentioned there that you can put a local controller in between the CSMS and the charging stations. But it's not defined further in detail. What it does, it basically says you have to replicate all the WebSockets from the charging stations towards the CSMS. So basically, the local controller is invisible for the CSMS because it just sees those WebSocket connections. And it also means that your CSMS is not aware of any network topology. And yeah, of course, if you get a bigger network, this does not really scale well. So we wanted to get a solution for that. So first, what kind of topologies do we want to support with OCPP? Well, of course, the regular client server that you see here, that should still be supported if you have a routing capability. And we want to have at least a single hierarchy level where you have one cluster, for example, but preferably also multiple levels of hierarchy where you have different routing nodes in between. And of course, we set ourselves a number of boundary conditions because if we're going to add networking, we want to be able to add it in a minor release of OCPP. So we don't want it to be completely breaking. You should be able to add it as a relatively small change. This also means that we have to keep the WebSocket mechanism. We cannot suddenly say we are going to change to MQTT or something. So we have to deal with the WebSocket transport mechanism. And ideally, we also still want to be able to use 1.6 or 201 charging stations, the regular ones, in the field. So you want to have a network where you can add your existing charging stations in this network. So then how do we add this routing without changing OCPP messages? Well, the idea is we have, of course, this OCPP RPC framework, which you see here, where you have a call, a message ID, payload with the JSON inside it. What if we wrap this OCPP framework in a routing framework? So the routing framework just takes the original OCPP framework as its payload, and it adds a source and a destination for the message. And of course, you need a little bit more information. We also add a payload type, so you can tell the receiver whether the payload is a 1.6 message or a 201 message, for example. And we also have several additional messages that you can send, which are not OCPP messages, but they are specifically to, for example, to set up the message, the network. It turned out that you need some messages to configure the network, and you cannot do that in a regular OCPP message. So in that case, you have a payload type of OCPP routing. And we also add the functionality to sign your message, so you can guarantee the authenticity of the message. In that case, the payload type becomes routing signed. And finally, at the end of the framework, we added a hops field. And the hops field just contains the list of all the nodes that your message passed through. It's not really required for the routing, but it will tell the CSMS exactly which nodes the message passed before reaching it. And with that, the CSMS can construct the topology of the network that it has. So to give you an example, I show here a simple OCPP boot notification as it is. And then if you put it in a routing framework, you see that it's simply in there, and on the top you add source, destination, and the list of the hops that is then extended as it goes through the network. So it's really fairly limited impact if you look at it that way. And because the original RPC framework is in the payload, that also makes it easy to support regular charging stations. Because if you have an existing charging station that is not routing aware, how can that be supported? Well, the node that the charging station connects to, we call it a controller node in our specification, adds the routing framework when it receives a message from the charging station and then sends it further upwards to the CSMS. And when it receives a routed CSMS message, then it takes the payload, unpacks the payload, and sends it as a regular OCPP message to the charging station. So that means that you can hide the whole network from the charging station, more or less. So now I will just quickly try to explain how the routing works. Because the network that we support is always going to be tree-shaped. Because there's a single CSMS on top, and then you get various branches. So the routing is not that complex. Because for the upstream routing, upstream meaning the message is going to CSMS, there's always only one way up. So sending a message to the CSMS is simple. You just send it over the upstream WebSocket. And when a charging station first connects, for example, it first sends its boot notification. I will show you the flow here. Here the station CS31 sends a message, goes to the routing node. The routing node knows, okay, this WebSocket is this charging station. Routing node forwards it to the next routing node. And then this routing node now knows from this moment on, okay, charging station 31 can be reached over this WebSocket coming from, what is it, routing node 3 in this case. And that forwards it to CSMS. And now CSMS knows, over which WebSocket it can reach this charging station. So then when the CSMS sends a reply or response to this message, it knows over which WebSocket to send a response, and the other nodes also know how to reach this charging station. So that's how we can support a routing, and we have already implemented in a small Python example, and that mechanism really works. Now we added one extra thing. I said there's always only one upstream route, but we did add the possibility to add an energy management system that can act as a parent to a local cluster. So you can have a situation where you have a local cluster of charging stations, which is connected to a CSMS, but it's also connected to an energy management system. And this energy management system is then allowed to submit charging profiles for the cluster. Now then we have the issue of what do you do if one of the nodes go offline? Because normally if a charging station goes offline, the CSMS immediately knows that because the WebSocket ping pong stops working. But if there's a node in between and someone goes offline, you might not know it. So the charging station might still think it's offline, and somewhere along the way, the connection is lost. So for that purpose, we had to introduce a separate message, a connection state message. And this is an example of the networking message that I mentioned. So this would be a payload type OCPP routing. And in there would be a message connection state telling it that this node is offline, and probably also telling which child nodes are then affected by this situation. And so you can tell other routing nodes where there is an offline situation, but you cannot tell it to the charging station because the charging station is not routing aware if you have a regular charging station. So if somewhere in the network the situation is that the connection with CSMS is lost, you can either at the lowest level disconnect the WebSocket with the charging station, then the charging station knows it is offline, or you can decide to locally handle the situation. So you could have a more intelligent controller node there that knows, okay, when I'm offline, I'm able to stop transactions or buffer all the meter values, for example, until the connection is restored. So because there are different offline possibilities now. Here you see that the red cross is the connection that has been lost that causes the offline situation. Here the charging station is offline, has lost its connection with its controller node. And then the controller node can send a connection state message to CSMS to tell it this station is offline. You can also have that the connection on the other side is lost. Here the top routing node loses this connection with the CSMS. So this routing node then sends a message downstream to its children saying, hey, I'm offline now, be aware of that. And then once the controller nodes could decide, then okay, then I close the WebSockets with all my child charging stations so that they know that they are offline. That's an option. It depends on how you want to implement that behavior. And then the third option is that not at the top or the bottom something is lost, but somewhere in the middle the connection is lost. So then you get connections from one node telling downstream that you're offline, and the other node warning the CSMS that some parts are offline. Both situations use the same connection state message, but just in a different direction. Now, of course, we have to support all existing OCPP security profiles. So if the basic auth, the TLS, and the TLS and client certificates are supported. But if you have these security, TLS security, for example, there's only node to node. So there's security between each node, but you don't have an end-to-end security from the charging station to CSMS. You can of course assume that all connections themselves are secure, but end to end, you have no certainty that there's not maybe a node in between that has been tampered with. So if you want to tackle that, then we support payload signing. So it's the same kind of mechanism that was already there for charging stations in OCPP, but I don't think it has been implemented anywhere. If anyone has implemented it in OCPP 106 or 201, I would really like to hear about it. But we extended it a bit to also be possible with routing. So then you can have that the original message is signed, and then the CSMS can verify all the authenticity of this that message. In any case, the CMS is going to be in control of the shape of the network. So the CSMS tells routing nodes whether they are, which channels are allowed to connect to them. So the CSMS always stays in control. You cannot just have a station connecting anywhere and then it's on the network. That has to be controlled by the CSMS with the configure allowed child connection message. So we're almost there. The use case that we support, well, the configuring of network nodes is described, how to report offline. Also, the case of using a node as a simple proxy, we describe it. And there we have 3 options that describe how you can do local load balancing, how you can do local authorization, and also how you can manage a local cluster if you're offline. But of course, we have this specification, ready by now, but we really like some pilot implementations to really verify that this works. Elate, our host here, has already built a routing node pilot, but of course it needs to communicate with a CSMS. So at the moment, Innovate just started working on creating a routing capable CSMS, and Drives has also planned to build this extension as a pilot for us. So as soon as we have that, then we will start testing with various charging stations and various nodes that this implementation really works. And that wraps up my presentation about the routing network. So, are any questions?
Die microfoon, hou mij voor je mond als je. We have room for one question. We have online questions, a lot of them, but yes, this is your chance.
Is this routing concepts is intended to create a complete mesh topology?
No, it's not a mesh topology. It is a tree topology.
Okay.
So you cannot go like horizontally in the tree. It's always top down.
Okay, thank you.
Okay, thank you. Let's see. I think Paul will take the stage now. Yes.
Hebben we de presentatie? Okay, just a second. Find the right presentation. Yes, that works. Okay, hello everybody. My name is Paul Klapek, and today I'll be updating you on the OCPP and the ISO 15118-20 task group, as it's called. For those of you that don't know me, I'm active as a technical editor and also active as the chair of the compliance working group. So we discuss the certification and the OCPP compliance test tool. So OCPP and ISO 15118. As you may know, we already have an integration with the ISO 15118-2 specification. So that is already released in 2018. And recently, in April, the -20 was released, which is basically the follow-up of the specification. And there was already a final draft international standard, FDIS as it's called, in October 2021. And then we, from the OCA side, we started a group to integrate also the changes from the -20. Currently, they are already available for OCA members as a draft. So you both have customizations or extensions, and we also have them available as new messages as draft. And currently, we are working on pilot implementations to see what we have come up with and what we have thought of, whether it actually works, which is of course good to know before we publish. And we are also currently, but that's done in the technology working group, discussing how we are going to release these changes, whether it's going to be extensions or maybe even a new release, but that's something that's up to the technology working group. And that's also the group that decides on the release date for this new functionality. So the approach, for those of you who are familiar, may already could have guessed this. Within the technology working group, when we have specific topics, we always create a separate task group. So this is also what we did for this topic. We started off weekly and then later bi-weekly to get a bit up to speed in the beginning. What we did is we created a list of things by just reading through it and just created a list of possible impacted parts for the OCPP specification. And for each of those things we found, we later went through them one by one and just went into the details to see whether it impacted OCPP or not. And of course, everything we found as a difference or something that impacts OCPP, we all wrote it down. We did this in an RFC, which then we can be further either as extensions or the new version will be available. So for those of you that don't know the functionalities, the functionalities from the -2 are listed here, and they also have a companion use case in OCPP. So you see the plug and charge authorization, the certificate management, and also the smart charging part for ISO 15118. In the -20, 2 new functionalities are also added, which is the wireless charging and the pantograph charging. It's the abbreviation is ACDP, automatic connection device pantograph, if I'm correct. But basically, it's pantograph down charging. So then what I want to do is I will just go through all these functionalities and shortly describe what the changes in functionalities are for OCPP. And then, yeah, we will not, or I cannot go through all of them. So we'll leave out some of the details, but for primarily the main changes we'll highlight. For the plug and charge authorization, that's actually quite a large one. Currently, you can only install 1 contract in an EV. So that's also supported by the OCPP specification, and that has been changed to multiple contracts. So that actually also means that you have to be able to fetch multiple contracts from the CSMS. Now, what we also took into account when creating this on our side is that we took into account that there might be multiple contract certificate pools, which also impacts the counter, which is actually in the response message within ISO 15118. So we also include a counter in OCPP that overrides that one, because if you have multiple contract certificate pools, there could be more than 1 certificate from each pool, and then you have to sort of update the counter to have them all. Otherwise, the charging station might think it's done, and yeah, it will stop asking for more. Sorry. Yeah, so what it's from the OCPP side, we will just update the counter. And of course, the charger also has to take that into account and communicate it to the vehicle. Now, besides the amount of contract certificates, there's also impact, and that you will see that in the entire specification on the size of the contracts, the size of the certificates, and also the length of the certificate change. The size of the certificate has been doubled. So it was, I think, 800 bytes, and it's now 1600 bytes. And for the certificate length, so the chain length, it's from 3 to 4. So it's now also possible to support, sorry. It's also possible to support cross certification. And there's an extra layer for that. So that's also included. So that's also what we included in OCPP to support that. So the next topic, certificate management. Now, as you can guess, of course, if the certificate chain becomes longer and the certificates become larger, this also impacts the certificate management. So the first thing is that this impacts, of course, everywhere where you see certificates. For example, for the EV certificate installation, there you will see that the size of the fields for that are, well, they have to be extended a bit. Same goes for all the places where we have certificate change. You also have to take that, of course, into account. Yeah, the second one, that's the OCSP response. So that's also one of the use cases in OCPP. And what we see there is when you fetch an OCSP response, it can actually contain a signature. And again, if the certificates are larger or the chains are longer, then you also have to have a larger message there. Then there's the two-side TLS, which is now on the vehicle to charger side. On the -2, there was a one-side TLS, so the server certificate was on the charger side, and the vehicle didn't have a certificate. This is now also added to ASSL, which means that the car now also has a client certificate. And on the CSMS side, we have to be able to install the root certificate that the charger can use for verifying the client certificate from the car. The specification of the ISO 15118 calls this the OEM root certificate. So this is also now added to the installation use case, the fetch use case, and the delete use case for the root CA certificates. And then there's the signature operations. That's, well, not really a big impact, but it's on the charger side, it has impact. But on the OCPP side, it's not a big impact, but the charger now has to be able to support another signature operation type. And finally, and that's also actually a big one, currently we have OCSP as the way of checking the certificate status. And in the -20, we also have certificate revocation list. So we also need messages for fetching a certificate revocation from the CSMS so that it can provide that to the charging station. Smart charging. Well, as you know, as already mentioned, smart charging is, of course, already integrated, but in the ISO 15118-20, there's also bidirectional charging added. Well, that's actually not part of this webinar. We have a follow-up which is called V2X, and that's where Frank, my colleague, will tell something about that. So that's in the next webinar. But of course, there's more. So for example, there's the new, which is called dynamic mode, where not the vehicle calculates the charging profile, but it actually, how do you call this? It's actually the charging station just immediately operates and just goes power up or down instead of actually giving the whole charging profile to the car. This is called dynamic mode. For the OCPP, it doesn't really matter for the messaging, but it does impact the use case a little bit. So the message is pretty much the same, but we did add some use case for clarifying how to do it in that way. Well, there's an extended set of charging parameters that's specifically for the max power, minimum power, max current, minimum current, especially of course for V2X. This is also important, but Frank will probably come back to that in the next webinar. And we have which also important, the charging schedule type in OCPP is extended with a number of things. Three of them are here on the slide. The first one is the power tolerance, which is actually the amount the charger can deviate, or the car can deviate from the charging profile that it has provided. So basically just making sure that it's within the limit. The price schedules are pretty more advanced. So we used to have sales tariffs where you had 3 levels and where you can choose basically based on these sales tariffs. And this is a bit more complex. So there are now price level schedules and absolute price schedules. And finally, there are optional limits per phase. One other thing which I think is interesting is now also possible to change the departure time of the vehicle. For example, if you have a bus and you want to have it to be preheating, then you can also initiate that. That's also added to OCPP now. Then we have the last topic, which is wireless charging and AC/DC charging, the pantograph charging. Those are the things that are still under development. So those are also in the ISO standard separate topics with separate messages. So that's pretty much makes them really separate for us as well. These topics are still under development. So far, what we've seen that there are not really changes in OCPP messages, but some device model information will be needed. So that will be added probably in the future, but that will be, that needs some more time. So that will be a future option. Now, I have spoken a lot about the impact, and I've shown a lot about the message, basically about the functionality. Just to give you an idea of the impact, I also have a list here of what has been impacted. So as you can see, even though it looks not very much when you exclude the V2X part, it's still quite a lot which is hit by the update of the specification. So that's also, yeah, well, I will not go through all of them, but yes, you can see it's quite a long list. That was it. So this is what I have for now as an update of this group. So maybe if there are any questions, then please let me know.
Let's see. Anyone a question about the presentation by Paul? I can check online, but I want to make a little bit faster because we have another presentation. Afterwards, we can ask all questions needed. So
I'll be available for 2 days, so
yeah,
don't worry about that.
Frank, next session. Maar voor je mond is makkelijk. Even mooi geluid.
Yeah, there it is. Okay, so my final task group presentation now is going to be about the V2X task group. And again, I start with talking about the goal of the V2X task group. Why do we do this? The kind of scenarios, usage scenarios that we intend to support with V2X functionality, and some pilot implementations that have been done. And of course, they end up with the current status of our specification. So what is V2X? In context for OCPP, V2X is about providing support for controlled discharging of EVs. So in a vehicle to grid scenario or a vehicle to building, vehicle to home scenario. And we see an increasing interest in V2X. I mean, it's really becoming like a kind of a hype. And until now, Shademo was already always supporting bidirectional power for DC. And now with ISO 15118-20, we have bidirectional support for both AC and DC. So we started our V2X task group already in 2019. And at that moment already, the aim was to support the upcoming ISO 15118-20 features for bidirectional power transfer. But we still wanted to remain compatible with Shademo. So our use case or our messages should also have to work with Shademo. And initially, a lot of input from the task group was coming from 3 companies, BMW, Costel, and Dreef, because they were all 3 involved in a pilot project with bidirectional power. Again, here, like the other task groups, we set ourselves some boundary conditions, which means that it has to be based on OCPP 201, and it should remain backwards compatible. So we don't want to
completely change messages for charging profiles, for example. We only want to extend them. So with our new V2X specification, we have only extended existing messages and added some new messages. And the idea was that it should be possible to implement the entire V2X functionality using custom data extensions in OCPP 201. But it turned out that it is quite a lot of extensions, so it might be wiser to implement it as a new release. So let me go through with you the kind of scenarios that we plan to support. We had two use cases: central setpoint and external setpoint, where a central system is the central system that sets a setpoint, and external is where an EMS, energy management system, sets the setpoint. Then we had three cases for net stability. So a use case for central frequency control, local frequency control, and voltage control with reactive power. And the last use case is that for local load balancing, for example, in a vehicle to home or vehicle to building situation. And then again, here you also have to deal with an offline situation. What are you going to do if you lose your CSMS connection? Can you continue with V2X or not? Should you stop it? How do you deal with that? And finally, we wanted a way for the user to overrule V2X. That if your vehicle is being charged and you say, no, I don't want any discharging now because I have to leave in an hour, I want to get full power. How can you overrule that as a user? A short, little bit more detail about these scenarios. Central set point is probably clear. The CSMS just sends a set point on how much to charge or discharge. The external set point, there we have basically two flavors. We can either have a CSMS in control of a profile, where a CSMS submits a profile, but it says during this charging schedule period, EMS is setting the set point, but the CSMS still owns the profile and can terminate it any time it like, and it can also set an upper and lower limit that the EMS can use. And the other option is where you completely give the EMS permission to set a charging profile, and then the EMS is in full control. In that case, it would be what we call a charging station external constraints profile in OCPP. Then for the frequency control, we have the central and the local option. For the central frequency control, the CSMS changes the power depending on the net frequency, but it probably means that the CSMS has to update the charging profile quite regularly. So we added some additional facilities to be able to modify an existing charging profile rather than have to submit a new one every time. But probably more practical for frequency control is to have local frequency control. In that case, the CSMS can upload a table with grid frequency power values, and the charging station will regulate independently based on that table what the charging power or discharging power is going to be. For voltage control, it's basically the same mechanism. The charge point measures the local voltage, and depending on the table that CSMS has provided it will change the amount of reacted power in that situation. And finally, the local load balancing. In this case, for example, for a vehicle to home situation, your charging station could be connected maybe to your smart meter and know what the energy consumption is. And then you can define an upper and lower threshold. And then your charging station will make sure that you stay within this threshold. So if you are going to use more power, then the vehicle will start discharging so that your net usage stays within the threshold. And if your home situation starts to discharge, solar panels, for example, then the vehicle will compensate with charging. Now, an interesting one was the priority charging. That's a situation where the user wants to overrule the discharging.
I think this concept was introduced by Dreef because they said, okay, we have the situation where the user allows his charging station to be used for frequency control, but what if he wants to leave urgency at some time? So there we introduced the concept of priority charging. And the way we implemented it is that you can define a new type of charging profile, priority charging. And if that profile is present, and the CSMS can then either trigger that the user wants to do priority charging, because maybe via an app connected to the operator, the user can say, okay, I want to do priority charging now, or the charging station can do it by the button on the charging station, and then it will activate the priority charging profile, and that will give you the maximum amount of power that is allowed for that user. And we initially wanted to call it Charge Now, but that was a registered trademark from a certain German OEM, so we decided not to use that. Yeah. Well, in the meantime, we have two pilot implementations that have been built. One by Dreef, that's a local frequency scenario. And they have over 150 V2G DC charging stations used for office chargers. And they're using the V2X messages that we defined. They didn't want to change the existing schema, so they put them in data transfers, but they were using the exact messages that we have defined. And they use it in combination with shadow mode chargers. And the other parties are BMW and Costal. And they have implemented the local load balancing use case and the central set point. They use it for intraday trading and peak shaving. And they have really used our V2X schema. So they replaced the original OCPP 201 schemas with our V2X extended schemas and implemented the pilot using those schemas. And there's a link here that you can follow if you want to have some more information about that project. So the current status is that we had to extend 4 messages. They are mentioned in the specification. I will not go into too much detail here now. And we had to add 5 new request response messages to allow, for example, for charge profile modification, so that you don't have to resubmit an entire profile each time. We have to deal with different kinds of allowed energy transfers, which is some 15.11a-20 feature. And we had some messages to support priority charging. So what's now the next status? I mean, we have all use cases defined, the messages are specified, the JSON schemes have been generated. And we managed to remain backwards compatible with 201. So any of the fields that have been added for V2X are all optional. And now it's up to the OCA to decide on how we're going to publish that. We were first thinking of custom data extensions, but it turns to be a pretty large change. And in fact, we think it's probably better to introduce this as an OCPP 2.1 release, a new minor release, which has to remain backwards compatible. So everything that you have built for OCPP 2.1 still works. The OCPP 2.1 would only add the new fields. And this is part of the basically the main topic of the technology working group discussion that we're going to have tomorrow. Do we want to have custom data, or do we want to have an OCPP 2.1 release, and what should it look like? So that wraps up my V2X Task Group report. I'll be glad to take any questions, Martijn.
Yes. Let's see. First question.
The OEMs, apart from Nissan and BMW, are they supporting the feature for vehicle to grid, or how do you see it?
Well, the OEMs have to deal, of course, with the vehicle to charging station aspect, and they will either support 15.11a-20 or or Shanamo. And both variants are supported by our messages, so that should work with them. Yeah. I don't know if that answers your question.
Well, for example, if an ID5 or 4 or whatever is coming out next year, do you expect that that feature will be supported?
Yeah, I expect that feature to be supported, and I also the Ionic 5 is now also already supporting vehicle to load, but I know that we have a pilot project here in the Netherlands where there are some Ionic 5s that have been modified to support vehicle to grid. Yeah, so that's really coming, and yeah, that will be supported by our messages. Yeah.
Thank you.
Let's see, I saw another question in the audience. Let's see what we got online. Let's see. Yeah, it's a more general question, I think, but can we know, it's shifting. Yeah. The power of vehicle to X charge from EV to a grid or home is limited by the regulations. Is that right? Are the regulations that limiting the charging from V2X to home?
Well, there may always be legislations where there are limitations, of course, but if you're just supplying energy from your vehicle to the home, I don't think there would be any limits, except that you have to stay within the limits of the fuses at your home, of course. But and of course, there's always the grid code that you have to comply with. But that's yeah, more of an electrotechnical issue that the charger has to take into account.
Okay. And a question, why do you want to implement a new message to modify a charging profile when you can send a new one?
Yes, well, you can always still send a new profile, but in the case of especially the central frequency control, the idea was that you probably might have to update the profile many times, maybe every minute or more often as the frequency is varying. And then it would be simpler to simply say, okay, I just want to update the second or the third period in the profile and not send the whole new profile. So we have now a message that supports that. You don't have to use it. You can also replace the entire profile if that's more convenient for you.
Okay, we have a follow-up question. Is this profile only applicable for V2X, or is it a use case to simply modify a charging profile?
It's a generic use case. So it was designed in the context of V2X, but you can also use it for regular smart charging. Yeah.
Okay, thank you. Well, looking at the time, let's see, I want to wrap this up. Thank you, everyone.